Hello, before we continue on with lesson 2 and learn another method for solving system of equations, I want you to practice solving by graphing again. So go ahead and hit pause right now. And then when you are finished, come back and check your answers. Okay, so when you graph this, you will see here that when we graph those lines using our slopes, we actually ended up with parallel lines, which means they never intersect, and your answer will be no solution. When you type this into the computer, you actually have to type that out. If you're writing it on your paper, that's enough. Okay, so one way to help you recognize that there be no solution is notice that my slopes are the same. And whenever the slopes of two lines are the same, they never cross. Okay, in the last lesson you learned how to graph. I actually hate graphing systems of equations to solve them because you have to be very careful and extremely accurate with your graphs. Instead, I prefer using algebra. So we are going to talk about two methods that we can use, one being substitution, one being elimination, to solve systems of equations. And I'm going to split this into two videos where I'm going to talk about the 2.0 stuff, just solving them, in the first video, and then the 3.0 stuff, actually using the applications for the second video. So I do want you to do both. You need to try both and kind of see where you get. So remember, substitution means you're going to plug something in. So think of a substitute teacher. If I can't be there, you can replace me or try to replace me with a substitute teacher. You still write your solutions either way as ordered pairs, so you have to find two numbers, an x and a y. So here's what we're going to do. We are going to start with this first problem. And anytime you have an equation that has a y equals there, or an x equals, you can take the part that it's equal to, so that there, and put it in place of the other y. So I'm going to take this and put it down here. So I'm going to grab my screen clip tool if I can, which I can't. So I'll grab a pen. Okay, so I'm going to take that 3x minus 11 and replace the y. So in place of that y, we're going to do 3x minus 11. We have the equal sign, negative 2x plus 14. So here it's extremely important that you know how to solve equations. Draw your line down. Move your x's to the same side. You get 5x minus 11 equals 14. And then move everything away from your x, so add 11 to get 5x equals 25, and divide by 5. So this goes way back to last semester when we were solving equations and told you it was very important that you know how to do that. And then after that, we're going to substitute. So if I know that x is equal to 5, I'm going to put a 5 in right there. Okay, that will help me find my y. So instead of having an x there, I'm going to do 3 times 5 minus 11. So 3 times 5 is 15. 15 minus 11 is 4. So my solution here should be the point 5, 4. Okay, and that's my final answer. Notice I put parentheses around it so that I know that it's an ordered pair. But I also want to show you how you can check to make sure you're okay when you do this. This point should work in both equations. We've already used the first equation to find that answer. I'm going to plug 4 in for y and 5 in for x in the second equation and see what happens. I get 4 equals negative 2 times 5, which is negative 10, plus 14. And negative 10 plus 14 is in fact 4, which makes me very happy because that means I probably did it correctly. Let's do a couple more. Okay, same thing here. I have a y equals, so what I'm going to do is I'm going to take this part here. Okay, so that 8x minus 10, I'm going to replace the y in the second equation with that whole thing. So I'm going to take this and put it right there. So when I do that, I have negative x plus 6, and then instead of y, I'm going to put in 8x minus 10 equals negative 13. And I need to solve. So this goes back again to last semester. We need to distribute and be really careful of our signs, and then go on from there. So 6 times 8 is 48. We have an x there. 6 times negative 10 is negative 60. I'm going to combine my like terms. Okay, so if I combine those together, I get 47x minus 60, because that's a negative 1 there. I'm going to add 60 to both sides, since it's subtracted. So I get 47x equals 47, and I'm going to divide by 47 on both sides. So I get x equals 1. Once I finish that, I'm going to take that 1, and I'm going to plug it back in up here. So I'm going to put that 1 in place of this x right there. So I'm going to find my y by doing y equals 8 times 1 minus 10. 8 times 1 is 8. 8 minus 10 is negative 2. So my answer is x is 1, y is negative 2. And I'm going to check it. In the second equation, I already used the first one to find that, so it should work. So negative x, which is 1, plus 6 times y, which is negative 2, should equal negative 13. 6 times negative 2 is negative 12. Negative 1 plus negative 12 is, in fact, negative 13. So again, I'm a happy camper. Looks good. I'm on the right track. Okay, the next two, they're actually special cases. So I'm going to do the same thing I did on the previous two. And I'm going to find the y, and whatever y equals, I'm going to put in place of the y in the equation above or below it. This tends to throw students off because it's not the first equation this time that has y equals. Doesn't matter, find the y, take that part, put in place of the y in the other equation. So I'm going to do 6x minus 2. I'm replacing the y with 3x minus 2 equals 4. And I'm going to go ahead and solve that. So I'm going to distribute, be careful of your signs. Negative 2 times 3x is negative 6x, and negative 2 times negative 2 is positive 4. Well, 6x and negative 6x cancel, so I'm left with 4 equals 4. Guess what? I don't have any x's or y's left. When that happens, I'm either going to have no solution or infinite solutions. We're going to talk about how to decide which one in a second, because I want you to see what happens on the next one. Okay, again, I'm going to go ahead and plug this in for y. So I'm going to do 9x, and I'm replacing that y, plus 3 times negative 3x minus 2 equals negative 2. I'm going to do the same thing. We're going to distribute. Watch your signs. And then negative 9x minus 9x cancels, so I'm left with this. Now, I have to decide which one's infinite solutions and which one's no solution. And all I want to do is ask you, which one are you going to tell me, no, it doesn't work? And I'm hoping you're going to say that negative 2 is not equal to negative 6. So this one has to be no solution, or write it out. Okay, because 4 equals 4, that's always true. Always, infinite, forever, solutions. Okay. That's it for this video. I'm going to go ahead and do the next part, the applications of 3.0s in the next video. So hang tight.